Okay, now we'll see the second part, that is in this question only. So this is second part. Okay, B to C FD is there, then D to A FD is there. Okay, so here we'll take again same thing. There is we'll be having the four relation, four attributes. Okay, A, B, C, D. So this is the new FDC given. Okay, so B to C he given, B to C. Okay, then D to A he given. So D to A. Okay, there are two FDC given. Okay, I will write this one as a F1. Okay, this I will write this one as a F2. Okay, so we have to identify the candidate key again. Okay, so we will write this one again, that graph. Okay, so that is B to C is there. Okay, so this B to C is there. Then D, so D to A is there. Okay, D to A. Okay, so here we have two attributes, that is B and D, which has incoming nodes as 0. Okay, so this is also a part of our candidate key, this is also a part of candidate key. So both these together is our candidate key. Okay, in this graph, whatever how many attributes has the incoming degrees as zeros, so those all will combine with those all together will form as a candidate key. So here these two together is our candidate key. Okay, that is B and D both together. Okay, so if you saw B and D both together, I can derive from B, I can derive C, from D I can derive A. Okay, so that is nothing but B, D both together, I can derive A and C. Okay, uh, now this is my candidate key. Okay, so CK, okay, is equal to, that is B comma D. Okay, both together is my candidate key. Okay, now we have to check above normal form is there in which, above relation R is there in which normal form. Okay, so here, so by default whatever is given it will be there in 1NF. Okay, so this is considered as it's there in 1F. Now we will see is it there in 2NF or not. Okay, so this is we had as a definition for this one. A relation R, if every non-prime attributes of A are fully functionally dependent on primary key. So if you saw here, C and A both are the non-prime attributes. So here C is dependent on B. Is it fully functionally dependent on primary key? No. Okay, this is partially dependent. Primary key is B and D together is my primary key. Okay, B and D both attribute together is my primary key. Okay, but C is dependent on only B. It's a partially dependent on primary key. So this is not there in 2NF. So because F1 is violated. Okay, same thing we'll check for F2. Okay, so A is dependent on D. Okay, that is nothing but it is again partially dependent on primary key. Okay, so here both both attributes, that is sorry, both FDs, okay, this one and this one both violates the, okay, 2NF. So now just we'll say this one is whatever R is there, that's by default it's there in 1NF only. Okay, now we have to derive it to the 2NF. Okay, so whatever partial dependency is there, that you have to remove it. Okay, so B to C, whatever we have, that will remove it. Then D to A, whatever we have, okay, that also will remove it. So we'll form this one single table. Okay, so this is single table B to C. Okay, so B to C F1, so whatever is there, this is F1. Okay, F1, and second table we are forming. Okay, so I will give this one name as a, this is the T1. Okay, so this second table as a T2. Okay, so here D to A is there, so D to A, D I will form as a primary key which is deriving A. Okay, so this is my F2. Okay, so the other two FDs. Okay, so now we'll check it, is it there the in 2NF or not. Is completely dependent on primary key. In this table B and C are there, C is completely non-prime attribute, C is completely dependent on primary key. So here A is non-prime attribute, A is completely dependent on primary key D. Okay, so both are there in now no, 2NF, both tables are there in 2NF. Okay, so while deriving this one, okay, so from R I derived as a these two tables T1 and T2. Okay, but here if you saw B and T both together we had as a primary key, but both together were not the, these attributes are not there in any of the table. Okay, so if I decompose this R into suppose T1 to Tn, okay, these attributes whatever we have, those are not there in one shot in any of the table, means there may be a chances of getting a spurious tuples. Okay, so whenever we'll form its join operation, there may be chances of getting a spurious tuples because B is completely uh, independent on D now here. Okay, both are not dependent each other because the T1 is in different table, T2 is in different table. Okay, so now to make this one as in same table, we have to keep in one table. So that is nothing but I'm keeping in here B and D both together in same table. Okay, and here I'm forming a one table attribute as a B and D. Okay, so this is whatever FDs we have, those all FDs already covered. Okay, this is a new thing I'm writing as a, okay, that is T3. So both these attributes are writing in one table only. Okay, so here these two together is my primary key. So why we are writing this one is in our BD both together we had say a primary key that we have to maintain it in our decomposition also. So whenever we will perform the join operation, you have to get the same result. For that purpose, we are maintaining B and D both together in a same table. Okay. So here B is independent of D and D is independent of B here in these two tables, T1 and T2. To make this one as a dependency of each other, B and D, so what we are doing in T3, we are writing this one. Okay. So this will form our total decomposition, that is from R we have decomposed to, that is T1, T2, T3. Okay, so now T1, T2, okay, so T3. So total three things we have decomposed. Okay, now we have to check is it there in the same thing, that is the 2NF or 3NF or what. Okay, so by default these are the primary keys, we don't have any non-prime attributes, and so this is there in 2NF also. So already we checked for T1 and T2, so this entire decomposition is there in 2NF. Now we'll check it for 3NF. Okay, so for 3NF transitive dependency, if you don't have more than two attributes in a single table, so by default transitive dependencies will not come. So this is also there in 3NF. So whatever we have, this is R, it was before, it was there in 1NF. Okay, so now uh, we decompose into T1, T2, T3. So this is there in 3NF. Okay, so this is hash normal form we are derived into 3NF.